Hey guys, this is Mrs. Vaught. I am re-recording my Unit 1 Day 2 lesson because somehow the sound didn't come up on the other one. I've got my little Amelia here, so hopefully she won't make too much noise for you. So today we're going to talk about graphing quantitative variables. Quantitative, of course, is data that are numbers where the average makes sense. So we have three different methods that we're going to use to talk about, or that we can use to graph quantitative variables. First one we're going to talk about is a dot plot. A dot plot is where you have um, dots above each one of the data values to represent the number of data values that are that number. That sounds kind of funny. I'll show you a picture in just a second. It'll make a lot of sense. A stem and leaf plot, you'll probably remember from like third grade. So we'll talk about it in a few minutes. Then we have a histogram, which is like a bar graph, but for quantitative data. And I'm going to show you how to create one of those. So the first thing we're going to do is we're going to look at this example on how to make a dot plot. So we have some data on the 2004 U.S. women's soccer team. And what we have here is we have the number of goals scored in the 34 games played during that season in 2004. So here are some helpful hints as to when you would want to make a dot plot over the other types of graphs. Let's see, I'd rather have this pen. So when to use a dot plot. So what you're going to do, you're going to use a dot plot whenever you have a bunch of the same data values. When you have repeated data values. So if, say we have basketball scores, basketball scores are fairly large numbers. They could range anywhere from, you could score 55 points in a game to 110 points in a game. But a lot of times, the scores aren't the same for every game. So what you'd end up with if you tried to make a dot plot of basketball scores is you'd end up with just a bunch of single dots. Here what they've done is they've made an x-axis. That's what it tells you to do, is to draw a horizontal axis, just a number line, and you label it with your variable name. So you always have to label any axis on the graphs that you give me. We talked about that when we did categorical variables yesterday. So you're going to name your axis, and then you're going to list go from the smallest data point to the largest data point. Make sure you don't skip anything in between. You can't absolutely, when you're labeling an axis or a number line, you can't skip values. And we'll talk about that when we do histograms also. So you label everything, and then you're just going to put a dot to represent the different data values. So what I would do is I'd start here at 3. I'd say, okay, I have a dot at 3. There's my little blue dot if you can see it. And then sometimes it's helpful if I mark through them. That way I know which ones I've used. And then my next data value is 0, so I put a dot above 0. And then all the way through until I finish. And see how tedious this would be if all of our data values were different. Then we'd end up with something like this where we just have a bunch of single dots. It wouldn't show any shape. It just wouldn't make a very good graph at all. Okay, so I think it's really self-explanatory. I want y'all to try this practice problem number 38. So get with a partner, someone around you, try to make a dot plot. If you'll notice here, we do have a lot of repeated values. This is kind of neat because it's the 2008 Summer Olympics. We just got done with the 2012. But notice how spread apart they are. They go all the way from 0 is your smallest, and 51 is your largest. So you are going to have to somehow find a way to count from 0 to 51. I like to sometimes just break off a number by 10 and then maybe just put the tick marks in between. That way you don't have to write the numbers 0 through 51, and that helps a lot. So make a dot plot of this data, and then pause the video while you're doing it, and I'll show you the answer whenever you get done. Okay, here's my dot plot. I've already written some stuff on it, I'm sorry, because I'm re-recording this video and these are my notes from it. So let me erase this, because this word isn't going to mean a lot to you right now, but you will understand what it means by the time you get done. Okay, so here's my dot plot. So if you'll look at woo, let's see, can I do it? Oh, crud. Okay, I give up. I'll just do that. You don't need that word yet. Okay, so if you look at how I spaced mine, I did actually put tick marks all the way from, I put a tick mark 50 times, but I didn't number all the way through 50 because that just gets too much. And I did have to use it, you could maybe have turned your paper sideways or done it on the back if you didn't think you would have enough room. So I labeled my x-axis, or my horizontal axis, right? You got to label your axis, or I'm going to take off points on your test. Don't forget that. Everybody always loses the points because they forget to label their axes, or they don't make a correct scale or something like that. I put a dot, had a bunch of zeros. We had a bunch of countries that didn't score any medals. And then we had some countries that scored a few, and then we had just a few countries that got a bunch of medals, and those are represented by the dots at the end. So I think it's fairly self-explanatory. Once again, make a dot plot if you have repeated values. If not, you're probably going to end up making a stem and leaf plot or a histogram. So let's talk about a stem and leaf plot. So we got to go back up here, right? We did that one. Okay, so let me define a word for you before we do that. So go back to the previous page. Forgot to look at my notes. And let's go all the way down. Oops, wrong one. And we're going to talk about a word called outlier, because this wasn't a vocab word that I gave you. So add this to the bottom of your page. Okay, an outlier is any data value that falls outside of the general pattern. So what we're going to do is we're going to go back and look at this graph, and I'm going to show you the outliers. I think it's pretty obvious just by looking at the numbers. You know, I said we had a bunch of values that were squished all there together at the beginning, and then we had just a few that were scattered off by themselves. So you could consider these values right here, if you see them highlighting them, these would all be considered outliers. Now, we actually have a formula that will allow us to calculate numerically whether or not a data value is an outlier, but we won't learn that formula until next lesson, I believe, or possibly the lesson after that. As of right now, if your homework or anything asks you whether you have outliers, then you're just going to make a good guess, and that's all that I expect from you right now. And good guesses are approximate, so you may think something is an outlier and your neighbor might not. That's okay. You can always call them approximate outliers, which is what we do on, say, like the AP Stat exam, just to make sure, you know, we're not definite about anything. That always happens in statistics a lot. We can't be definite about much in statistics. Okay, so here now let's talk about stem plots. So I bet now that you've seen a picture of one, they kind of have jogged your memory. So here's a stem plot right here, where you're going to take and you're going to split the data up in terms of its digits. you're going to put the left digit on the left side. So in this case, we have two digits. So we have, say, the data value 3 and 8. So we're going to split the data up between the ones and the tens digit. And then we're going to put the ones digits on the left side and all the 10 digits on the right side. And we're going to line them up. So here we have 1, 2, 3, 4. If we can look at this line right here that I'm circling, data values that are in the 30s. So we're going to take and we're going to put all of the tens digits to the right of the 3, and this would represent those numbers 30, 31, 34, and 38. So they kind of give you some decent instructions on how to make a stem plot. I think it's fairly obvious. I almost think I could have just given you this lesson on your own, although the histograms are kind of funny, but I mean, y'all have made stem plots since elementary school. We do have a couple extra things that we do with them in stat that you may not have seen before. So all these instructions, they're good, read over them. I assume you can make a stem plot. I will tell you, though, that I have looked at several things, and it is not required on the AP exam that you order your leaves, although it does kind of make things a little easier if you wanted to use a stem and leaf plot to, say, find the median or find your quartiles. We'll talk about those later. Then it would be really helpful if they were ordered. But you can still get the shape of the graph and all of that interesting information if they're not ordered, so it doesn't really matter. Okay, so here's a few interesting things that we can do talking about um, stem and leaf plots. We have two things we can do. We can split stems, which is what this example down here has you to do, or what they've done actually, sorry. Or we can make what's called a back-to-back stem plot, where we compare two distributions. We use the same digits like on the right side that we do for both of them, and then we put the data values on both sides. That would be a back-to-back stem plot. Let's talk about splitting stems just a minute. So when you split stems, you're going to do this when you have too many data values in one or a few stems. Now this is kind of subjective. You're going to use your eye to see whether or not you think that there might be too many data values in a particular stem. Say you have 50 data values and 20 of them all end up in one stem, then you might consider splitting your stems. Now you can split them any way you'd like as long as you have an equal number of data points in each one. The one that you'll work with the most, and I probably wouldn't worry about any of the others, is going to be splitting into two stems. So to split into two stems, what you're going to do is you're going to put digits 0 through 4 in the first stem. And then you're going to put digits 5 through 8 in the second stem. 5 through 9. I'm retarded. Golly, summer. Okay, sorry. I think I would know my digits. I'm a math teacher. Okay, so here's an example. Let's look at the 14s because they have a 5. So they have 14.0, 14.0, 14.4, 14.4, 14.5, 14.6, and 14.7. Those are all data values. Now notice, how did I know it's not 140? I'm sure, I mean, you can't answer me, obviously. I'm talking to an empty room. But this is also very important, and I've seen points deducted on the AP exam for not including a key. For any graph that you create, the reader should always be able to gather all the information they need just from the graph. So looking at this stem and leaf plot, I really don't know whether 140 represents 140 or 1400 or any of those. So you make a key. So what you're going to do is you're just going to say, and you don't even have to write a sentence like that. You're just going to say something like 11 line 6 is equal to 11.6%. And that's fine. As long as you let the reader know what exactly those stems and leaves represent, what digits. Okay, so let's talk really quickly about this back-to-back stem plot. I think you might have a homework problem kind of over this question. So back-to-back stem plots allow you to compare. So we're looking at the number of shoes for males versus the number of shoes for females, which is kind of interesting. You would expect, I think, women to have more shoes. Maybe that's a gender stereotype. If you're offended, I apologize. But I would expect the men to have a fewer number of shoes here, and then women to kind of spread across the board. So we're very easily, the data is very easily comparable when it's written in this form. Notice that we have all of the stems that we need for both data sets written down the middle. So the smallest data value that I have is 4. So there is a man who only owns 4 pairs of shoes. That would be my husband. I think he has like 2 pairs that he wears, and that's pretty much it. So this represents 4. And then there's a woman that owns 75 pairs of shoes. I must have a separate closet for everything. And notice that I put my stem all the way from the smallest male value to the largest female value. And this is what you'd have to do to compare. Since you're going to share stems, they have to go from the smallest data value in both sets to the largest data value. And don't forget to include your key. Okay, what I'd like for y'all to do now is to take this data right here in problem number 45, read these instructions, and make a graph without splitting stems. So you're going to combine the stems together, and then comment why splitting stems could be helpful in this case. So pause the video, make your stem and leaf plot. We're going to come back and talk about it. Aha, here it is. Okay, so here is our stem and leaf plot. Here's our problem. So what I've done is I have taken and I don't really know what this means right here. Let's erase this. These are some notes from something else I was talking about. Okay, so we are going to take, oh, that's the title of our graph. That makes sense now. So we took, and all I did was combine the 2 stems together. So I didn't actually have you guys make a stem and leaf plot because I thought it would be a little tedious. I just had you go through and put all the stems together from the other. Notice that I put my key here. So don't forget to put a key. We're also not going to worry about this word right here. Here are my comments. I thought my stems were a little too long compared to the amount of data that I had. So I didn't really know if I could get a very good feel for the data, the shape, without splitting the stems, because I had this one stem, right here that was very long. I think that should be another 9. Also, I had a gap, if you noticed on the other graph, between 15.1 and 16. which is pretty important. I mean, I could call 16 an outlier, 16%, or I could not. It just depends on how you look at the graph. But as of right now, I cannot see this gap between 15.1 and 16. It kind of looks like a natural progression. So that would be another comment. It could be, as I've written down here, a possible outlier. I don't really know. I don't know if we'll come back and actually calculate it for this problem, but you could do that after next class when I show you the formula for calculating outliers. Okay, so one thing you're going to need today for this lesson is you're going to need a calculator. So we're going to do a few things on the calculator now that we're dealing with quantitative variables. I do want to look at, sorry, this example right here. Okay, so what we're going to do, I'm going to pull up my calculator on the computer, and then y'all are also going to get out your calculator. Mr. Elkins, if you haven't passed out the calculators yet, you can go ahead and pause the video and pass them out now. So I need my calculator. Where is it? I know it's on my desktop, so let's look there. Uh-oh, is it not? There it is. Sorry, guys. So all that I'm going to show you today, we can make histograms, which is what we're going to talk about in just a second on the calculator, but I'm more interested in the logistics of making one today. When we talk later about describing distributions and other things, I might show you how to actually create one on the calculator. We don't need this. Okay, so everybody has their calculator ready? Correct. I'm going to clear this out so you can see. All right, so we are going to be putting a lot of data into our calculator, and so this is just going to be good practice for us. So what we're going to do is we're going to take all of this data from the example that we have right here over talking about the state residents, and we're going to put this into a list in our calculator. And then we're going to put it in order. And this one, we put the data in order, it's going to make it a lot simpler for us to create a histogram. This is also true for making a dot plot or a stem and leaf plot. So if you come across a question, you don't want to have to go through and tally off all the data values. You can do this exact thing I'm about to show you and put all the data in order in your calculator and then just go through. I'll show you. It'll be easy. Okay, so in order to put data in the calculator, if you don't know how to do this, we're going to press this stat button right here. So obviously it's statistics class, we're going to be using this button a lot. And then how to input data in is to hit enter on edit. And this will show you your lists. Now if you notice, I have things in both L1 and L2. I want to show you a couple things. The first thing I'm going to show you is how to clear the data out of your list, and then I'm going to show you if you happen to delete a list off your calculator, how you can bring this list back. And these will just be helpful because I'm constantly in class, you know, oh, I don't have an L1, I deleted it on accident, fixing it for you, now you'll know how to do it yourself. Alright, so first let's talk about clearing a list. So the first thing that you'd need to do is you need to go up and highlight the name of the list. So if you see I have my little icon here, my square, whatever, highlighting L2. So I'm going to then press clear. What you're not going to press is you're not going to press delete. If you hit delete, the list will go away. We're going to press clear. Notice that now this line down here is blank, and if we hit enter, then we have an empty list. So it's up, clear, enter if you're starting at the first space. Okay, so now let's talk about L1. Let's go and clear it also. So y'all practice doing this. Go up and highlight the name, clear, and then enter. Alright, so let me show you what would happen if you hit delete on accident. So we're going to go up. We're going to hit delete. Oh crap, I lost my L1. So now what we're going to do is we're going to insert a new list. And if you've ever done this, say with like something on your calculator screen, you can insert things. That way you don't have to retype if you forgot a parentheses or something. And to do that, you press second, delete, it says INS at the top. That's going to insert something. So what this has done is this has inserted a blank list. And now I just want to name the list L1 because that's the one I'm missing. Now don't go alpha L and then 1. You have, see above the 1, 2, 3, 4, 5, and 6, you have your list names. You have L1, L2, L3, and so on. So I'm going to press second 1, and that will name my list L1, and then I hit enter. And now I have my list L1 back. So if you happen to have deleted or you end up with one of my calculators where you're missing an L1, then, or an L2, whatever, then that's how you're going to go about getting it back. Okay, so now you're at your list. I'm going to go down and where I put my data in, put my cursor there, and then we're going to go through and input all this data into our calculator. It will take you a few minutes. You're going to be a little slow at first. What I would also like for you to do when you get done, pass it off to your neighbor and have them check the data for you. If you mess up a number, it's really easy to mess up sometimes, especially if you're going fast. So hopefully after we do this a few times, you'll have the hang of it. And I'm going to pause my video also because I don't want you to sit here and watch me input my data. So y'all pause, put in all the data, and then press play whenever you get done. Okay, I hope you all have your data in your calculator. And it should look something like this. One of the things you can do to kind of help ensure that you've done things correctly is you can check and see how many data values you actually have in your list. And so if you'll go up and highlight your very last data value at the bottom, notice this 50 right here below the, or next to the L1 at the bottom left-hand side of the screen. That will tell you what position you're at. So this tells me I'm at the 50th position. There are obviously 50 states, so I at least got that right, that I have the right number of data values. Okay, so what we're going to do is we want to order the list from the smallest value to the largest value. So I press second and then I press mode here at the top, and that quits me back to my home screen. If I ever say, hey, quit and go back to your home screen, that would be the function that you would do. So now that we're back at our home screen, we're going to press this stat button again. So pretty similarly to what we did before, except instead of going under edit, we're going to go under sort A. So I'm going to go down. I'm going to hit enter on sort A. And this means sort ascending. Ascending means smallest at the top, largest at the bottom. If for some reason you wanted it to be descending, meaning the largest at the top and the smallest at the bottom, you could do sort D, but I never use that function. I always just sort smallest to largest. So we do sort A, and then I tell it what list to sort. So I showed you down here before, above the 1, 2, 3, 4, 5, 6 keys, you have L1 through L6. So we are going to select list L1. So we're going to press second, and then we're going to press 1. And then we're going to close our parentheses, and we're going to hit enter. And it just says done. So now if we go back and look at our list, it will be in ascending order. So I'm going to go back and look at my list. I'm going to press stat, hit enter on edit, and now it's going to go from smallest to largest. All right, so this will help us to make a histogram. It'll also help us to do lots of other things with graphs. So we got to get through this kind of quickly because we've been here a while. So anyway, so to make a histogram, it's just a bar graph. But instead of having different categories, like, you know, red, yellow, silver, and white for car color, whatever, we have groups of numbers. So we have a bunch of data values here. They go all the way from, let's see, where's my calculator? 1.2, that's the smallest. If I go up twice, I can see the bottom of my list, to 27.2. So we want to divide this into different categories. Kind of a good, we call these categories classes. Uh-oh. That's still working. Okay, here we go. So we divide our data into classes, and this is what this says right here. And then we want usually between 5 and 10 classes. You can have a few more if you have a lot of data values or they're really spread out. I probably wouldn't do any fewer than 5 classes, or you won't have a good shape on your data. Now, what you want to divide your data into classes that are going to make it as easy as possible for you. So I have, and actually in our regular statistics textbook, they tell you kind of a crazy complicated way to do it. But what we're going to do is we're just going to go through and say, okay, 1.2 to 27 or so. I think I'm going to go from 0 to 30 in terms of fives. Kind of the way that I would mark the tick marks on my x-axis. If I were going to somehow plot all these as points, I would say, okay, I'll start at 0, I'll end at 30, and then I'll just label every 5. So this is what we're going to do. There's no right or wrong way to divide this into classes. I definitely wouldn't count off if you used a different method than I did, as long as it was accurate. One of the things you have to know is that all of your classes must be the same width. And then another thing is that you have to define, like if I say 0 through 5, 5 through 10, we have to say, okay, which group is 5 going to go into? If I have one that's exactly 5%, what group would it go into? So in order to take this into account, we would write our classes in that manner right there. 0 to less than 5, which means that 5 is not included in that class, right? But it is going to be included in the next class. So you don't want any overlap when you break up classes. Okay, so we could go through and I'm going to show you kind of how to count this out. We're not going to do it all. They've already done the counts for us, but let's look at our calculator. So I'm going to go back. If I press down, I start at the top. So I need to know how many data values I have between 0 and 5. So I'm just going to go down and count. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, oh, 20, which is what they got also. So that would be the count. And then what happens is we call these counts frequencies. And this is going to be the height of each one of the bars in our histogram. So we say, okay, we're going to make a bar from 0 to 5, and we have 20 data values between 0 and 5, so that's going to be the height of our bar. So if we go down here and look, here is our just regular histogram. We're going to talk about the other one in just a minute. It's relative frequency. It's just percents. So here we made a bar from 0 to 5, and the height of this bar is 20. And then now we're going to take and we're going to count the data values between 5 and 10. If we go through our list and count, we have 13 data values between 5 and less than 10. And so our next bar from 5 to 10 is going to have a height of 13, and we do this for all of them. It's pretty simple. Now let's talk about relative frequency. This is just the percent of the whole. Oh. So if you notice, we counted before, we realized we have 50 data values that are there. And so, because 50 states. So if I wanted to know what percent of my data fell between 0 and less than 5, then I would just take my frequency 20 and divide it by the total number of data values. And I get a percent, 40%. So you can also make a histogram of relative frequency. And here you would go through and do this for all of them, create the percents. That's where all these numbers came from. And then you could also graph on your y-axis the percents instead of the actual count. And the shape of your graph should be the same on each one. Now, depending on how you label your y-axis, it could be a little bit different, but it should have approximately the same shape on each one. Okay, so here are some helpful hints about histograms. And I want to tell you a few other things also. So for histograms, you're only going to use quantitative data. Bar graphs are categorical. In histograms, you never skip spaces between your classes. You know, we went 0 to less than 5, 5 to less than 10. So they touched, they backed up right against each other. And so since we're using a number line as our x-axis, we have to make sure that those bars always touch because there is no gap between less than 5 and 5. You know, it's going to go right up next to each other. In bar graphs, we generally do leave spaces, although it's not required, just to kind of have some difference between the two and to show that those aren't numbers at the bottom. It kind of makes for a different graph, although it's not required that you leave gaps. Always make sure you label your axes and you scale appropriately. Okay, so here is a practice problem I'd like for y'all to do. I'd like for you to make a histogram of this data. So what you're going to do is you're going to take all this and put it in L1 in your calculator, order it, go through and make your classes. You can make your classes however you like. I don't care about the width. And then count the frequency of each class and then make your histogram. So I'm going to pause this and then we're going to come back to that. Okay, so let's look at this histogram. Here we go right here. So I made my classes. I went from 10 all the way to 55. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 classes. And then I just did, and I counted the frequency for each one. So if you look here, I've kind of written a bunch of other things here, but there we go. All right. So here I have, excuse me, labeled my x-axis appropriately. I have taken and put in my frequency on the y-axis. Now, if I wanted to create relative frequency for this, I would just have to figure out how many total data points I have. I see up here I have 44. And then I would just divide each one of these by 40 for each one of the frequencies. And that would give me a percent, and I could graph percents if I'd liked. This is just a regular histogram, though. So I marked the height for each bar. And I think it's pretty self-explanatory. I labeled my x-axis, I put a title, I labeled my y-axis, all things that you have to do. This little thing that I have marked in red here, this indicates that I jumped scale. I started at 10 instead of starting at 0. You can only do that at the beginning of a graph. You can't do it in the middle. If you ever have a big jump in the middle of your data values, kind of like that dot plot at the beginning with the Olympic gold medals, you want to make sure that you leave that gap because it's important. We want to see those big gaps in data values. We don't care to see how far it is from 0 with the gap between 0 and our starting point. So this is the only time you can use this mark right here is at the beginning of the graph. And you can use it either on the x or the y-axis. It doesn't matter. All right, so I have one more thing that I want to talk to y'all about, and this is about shapes of graphs. This is the last page, and this is pretty self-explanatory. I just wanted to go through and show you. I kind of gave you a little written description of all your different shapes, and then I gave you pictures of what the shapes look like. Okay, so here we have, for a symmetric graph, we have several other things that we can call this. We can sometimes call this normal. You'll sometimes see it called bell-shaped or a bell curve. And AP really likes to call it mound-shaped. If I can spell mound. Okay, so here is what okay, sorry. So for symmetric, is our graph down here for our symmetric graph. You see the first one top left. So it's going to be symmetric. There are a lot of different graphs that we could consider symmetric. Notice that this has little gaps in the peaks. It's never going to have a perfect bell shape. I guess every once in a while it will, but I mean, real life, in the real world, generally things are never going to be perfectly normal, but we would say approximately symmetric or roughly symmetric. Those are good words that we will use. Skewed right means that we have a high peak on the left side and we have a tail on the right. And this is how I always remember the difference between skewed right and skewed left. For skewed right, our tail is on the right. For skewed left, our tail is on the left. Unimodal is kind of similar to symmetric. It's not really a word that we use a lot. It just means that it has one peak. Multimodal means it could have a bunch of peaks, and I didn't show you a picture of that here. Let me label these. Right, I'm really bad with my right and my left too, so I probably will screw this up at some point. And then over here we have a bimodal graph where we have two peaks. And this is a shape that we will talk about some. It's kind of tough to pick out the bimodal graphs. If you just have a graph, kind of like the histogram that we just did for that previous problem, where you only have one class that's smaller than the rest, unless you only have a few bars in your histogram, I probably wouldn't consider that bimodal. Notice here that we have an obvious raising up to the top of the peak and going down amongst our classes. If you're going to call something bimodal or skewed right, it needs to have an obvious double peak or an obvious skewness to it. Unfortunately, the shapes of graphs are fairly symmetric, so it's always are fairly subjective. That's the word I'm looking for. So it's always nice to kind of throw in that word approximate or roughly. It's roughly symmetric. So just to give yourself a little bit of a cushion in case you happen to misread the shape of a graph. Okay, so I think I'm finished with Unit 1, Day 2. I'm going to have to come back up, I guess, tomorrow and re-record Unit 1, Day 3. So hopefully I can get you all caught back up. And I guess that's it. Do your homework, turn it in tomorrow, next class, and I'll see y'all later.